Processes using secure design principles. A principle is defined as a general or fundamental truth. Secure design principles are the fundamental truth upon which systems are built in order to be resilient against attack. Secure design principles reduces vulnerability and mitigates risk. Salzer and Schroeder's design principles are design principles by Jerome Salzer and Michael Schroeder in their 1975 article The Protection of Information in Computer Systems. Salzer and Schroeder's principles are economy of mechanism, fail-safe defaults, complete mediation, open design, separation of privilege, least common mechanism, psychological acceptability, work factor, and compromise recording. Economy of mechanism. Keep the design as simple and small as possible. Fail-safe defaults. Fail-safe states that the system should reconfigure itself to default or no access and avoid the failed components affects the normal functionality. Complete mediation. Every access to every object must be checked every time. Open design. Design should not be secret. Separation of privilege. Separation of privilege. Separate users and processes based on different levels of trust, needs, and privilege requirements. Least privilege. Least privilege is giving a subject or process only the privileges it needs to complete a task. Least common mechanism. Minimize sharing components between users, especially when the component must be used by all users. Psychological acceptability. It is essential that the human interface be designed for ease of use, so that users routinely and automatically apply the protection mechanisms correctly. Work factor. Work factor is the degree of effort required to compromise the security control. Compromise recording. Record compromise of information can be used in place of more elaborate mechanisms that completely prevent loss. ISO/IEC 19249. In 2017, the International Organization for Standardization, ISO, published its first revision of Standard 19249, Information Technology Security Techniques Catalog of Architectural and Design Principles for Secure Products, Systems, and Applications. ISO 19249 is to describe architectural and design principles to be used to develop the secure development of systems and applications. ISO/IEC 19249 Architectural Principles. 5 Architectural Principles from ISO/IEC 19249 are: Domain separation, layering, encapsulation, redundancy, virtualization. Domain separation. Domain separation: separate data, processes, and administrative tasks. Layering. Layering separates hardware and software functionality into modular tiers. Encapsulation. Encapsulation takes information from a higher layer and adds a header to it, treating the higher layer information as data. Redundancy. Redundancy: providing multiple instances of either a physical or logical component such that a second component is available if the first fails. Virtualization. Virtualization adds a software layer between an operating system and the underlying computer hardware. ISO/IEC 19249 Design Principles. 5 Design Principles from ISO/IEC 19249 are: Least Privilege, Attack Surface Minimization, Centralized Parameter Validation, Centralized General Security Services, Preparing for Error and Exception Handling. Least Privilege. Least privilege is giving a subject or process only the privileges it needs to complete a task. Attack surface minimization. Attack surface minimization is to reduce the overall risk by reducing the attack surface area. Centralized parameter validation. Ensuring that parameters are valid is common across all components that process similar types of parameters. Centralized general security services. The principle of centralizing security services can be implemented at several levels. At the operating system level, your access control, user authentication and authorization, logging, and key management are all examples of discrete security services that can and should be managed centrally. Preparing for error and exception handling. Systems must ensure that errors are detected and appropriate action taken. Defense in depth. By using combinations of security controls, the impact from the failure of any single control can be reduced if not eliminated. In 1972 by James Anderson in Computer Security Technology Planning Study. Security functions need to be implemented in a manner that prevents their being bypassed, circumvented, or tampered with. Security functions need to be invoked whenever necessary to implement the security control. Security functions need to be as small as possible so that defects are more likely to be found.